In this module, we will look at the aircraft's pneumatic system. We will start out with a system description. Next, we will look at the bleed air provided by the engines and the cross-bleed valve which connects the left and right side of the pneumatic system. We will then look at the alternate sources of pneumatic air, the APU and a ground cart. Finally, we will look at the bleed protection system and the controls and indicators associated with the pneumatic system. The pneumatic system is designed to supply high-temperature, high-pressure air for use by the anti-ice protection system, the air conditioning and pressurization system, as well as for engine starting. The pneumatic system is divided into the left and right sides. They are interconnected by a cross-bleed valve. The sources of air for the pneumatic system are the engines, the APU, or an external air ground cart. The APU supplies bleed air to the left side of the pneumatic system, whereas the external ground cart supplies air to the right side of the pneumatic system. The APU, or external air, normally supply the pneumatic system prior to engine start. Note that the air supplied by the APU should not be used for anti-icing or anti-ice testing. The engines normally supply the pneumatic system after engine start. The pneumatic system uses approximately 8 to 12% of the air volume when the air is supplied by the engines. The system sends signals to other pneumatically operated systems and prioritizes the various system supplies depending on aircraft flight configuration. We will now look at the engine bleed air system. Engine bleed air is supplied either by the low pressure or 9th stage compressor or by the high pressure or 14th stage compressor. The source of air depends on the system demands. A high stage valve, or HSV, is installed in the high pressure line. It functions as a shutoff valve. It is electrically controlled and pneumatically actuated. A signal from a pneumatic pressure sensor operates the valve open or closed. Valve operation is completely automatic. The only way to disrupt the operation of the high stage valve is to pull the circuit breaker. The high stage valve automatically opens during low engine thrust operations, engine cross-bleed starts, or during engine anti-ice operations. The high stage valve fails in the closed position in the event of a loss of electrical power. As bleed air increases, the high stage valve closes and a 9th stage bleed valve allows 9th stage air into the system. This bleed valve is called the bleed air check valve, or BACV. The bleed air check valve prevents the backflow of high pressure air into the low pressure compressor section of the engine. A check valve is installed in the high pressure line to prevent low pressure air from entering the high stage compressor. The high stage valve is allowed to open when the selected bleed valve is open, the associated fire handle is stowed in its normal position, and manifold pressure is below a certain value. As discussed previously, the high stage valve will open when the wing or stabilizer anti-ice is on. When engine thrust is low, such as during an idle descent, the high stage valve opens and high pressure air is supplying the pneumatic system. As thrust increases, the high stage valve automatically closes and the low pressure air is supplying the pneumatic system. If anti-ice is turned on, the high stage valve will automatically open. High pressure air is tapped prior to the high stage valve for use by the engine inlet anti-ice. The air supplied by the compressor is hot. The bleed air is routed through a heat exchanger known as the pre-cooler. The purpose of the pre-cooler is to maintain the bleed air temperature below 570 degrees Fahrenheit. In reality, the pre-cooler does a good job of maintaining the bleed air temperature between 510 and 570 degrees Fahrenheit. Click on the Show Me button to see the pre-cooler exhaust. The bleed air is cooled when the fan air valve opens and allows cool fan air to flow across the heat exchanger. The fan air valve operation is completely automatic. The valve position is controlled by a fan air control thermostat located downstream of the heat exchanger. As the temperature of the bleed air increases, the fan air valve is commanded open. This increases the flow of air through the heat exchanger and increases the cooling of the bleed air. As the temperature of the bleed air decreases, the fan air valve is commanded closed. If the bleed air temperature downstream of the heat exchanger exceeds 305 degrees Celsius, the ICAS will display a red bleed 1 or 2 over temperature warning message. A bleed air valve located downstream of the pre-cooler controls the supply of pneumatic air to the pneumatic system. The valve allows pneumatic air to enter the pneumatic manifold. The bleed valve is electrically controlled and pneumatically operated. The bleed air valves are controlled by the bleed air switches located on the overhead panel. The switches are labeled Bleed 1 or Bleed 2. When the bleed air switch is selected off, power is removed from the engine bleed valve and the high stage valve. Since both of these valves fail in the closed position, they will automatically close. Click on the left bleed air switch to select it to on. When the switch is selected on, the associated bleed air valve will open, provided the associated essential DC bus is powered, the associated engine N2 is above 56.4% RPM, the associated fire handle is not pulled, and no bleed leak has been detected downstream of the pre-cooler on that side. The bleed valve is also controlled by the associated engine fire handle. When the fire handle is actuated, the associated engine bleed valve automatically closes. The control panel on this screen is interactive. At the conclusion of this audio, we will simulate an engine fire. You can then pull the fire handle to see how the bleed valve reacts. After engine start, the left and right bleed systems are normally isolated. A cross bleed valve, or CBV, allows the left and right systems to be interconnected or isolated as conditions require. The cross bleed valve, or CBV, is located in the cross bleed duct which connects the left and right pneumatic systems. The CBV is electrically controlled and pneumatically operated. Click on the Show Me button to see a picture of the crossbleed valve. The crossbleed valve is controlled by the crossbleed knob located on the overhead panel. This knob has three positions: closed, open, and auto. In the closed position, the cross bleed valve is closed. Click on the cross bleed knob to select it to the open position. When the open position is selected, the cross bleed valve will open and pneumatic air from both systems is allowed to flow into both systems, provided essential DC bus number 2 is powered and no leak has been detected downstream of the pre-cooler or in the rear electronic compartment. The auto position enables the cross bleed valve to position itself automatically. Normally, the cross bleed valve is closed. In the auto mode, the cross feed valve is automatically commanded open or closed in order to select one of the available pneumatic sources for engine start, the APU, a ground cart, or the opposite engine. The cross bleed valve logic automatically opens the cross bleed valve and both high stage valves and closes one air conditioning pack whenever the anti-ice system is operating below 24,600 feet. If both packs are operating normally, the system logic will shut down the left pack. If one pack has failed, the logic will keep the remaining pack valve open. On aircraft equipped with pressure regulating and shut-off engine bleed valves, the functional logic also opens both high stage valves and closes one pack below 24,600 feet, but does not open the cross bleed valve if the anti-icing system is operating. The pneumatic system can also be supplied by the APU. APU pneumatic air can supply the pneumatic system while the aircraft is on the ground or in flight. Its primary purpose is to provide a source of pneumatic air for air conditioning and engine start. APU bleed air is normally supplied to the left side of the pneumatic system. The APU pneumatic system is connected to the aircraft's pneumatic system through an APU bleed valve. The APU bleed valve, or ABV, is controlled by the APU bleed switch on the overhead panel. A one-way check valve downstream of the APU bleed air valve prevents existing pneumatic system pressure from flowing back into the APU. The pneumatic system logic gives priority to the engine bleed air over the APU air. The APU bleed valve automatically closes when the left engine bleed valve is open or when the right engine bleed air and the cross bleed valves are open. The purpose of this system is to prevent any backflow of pneumatic air into the APU. The control panel on this screen is interactive. For this scenario, the APU and both engines are operating. You can use the controls to set the pneumatic system as desired. If neither engine bleed valve is open, the APU bleed air can supply both air conditioning packs if the cross bleed valve is open. If the cross bleed valve is closed, the APU would only be able to supply the left pack. A ground pneumatic cart can supply high-pressure air to the pneumatic system. The ground cart connects to the right side of the pneumatic system, and a check valve prevents backflow into the ground cart. The purpose of the ground cart is to supply air for engine starting. The pneumatic system is monitored by leak detectors located throughout the system. These leak detectors are thermal switches. When a leak is detected, a signal is sent to the ICAS and the appropriate bleed leak warning is displayed. The leak sensors are located around the engine bleed valves and the APU bleed valve. The bleed temperature on either side of each pre-cooler is monitored by temperature sensors. The temperature of the bleed air downstream of the pre-cooler is displayed on a vertical bar on the MFD. Click on the left pre-cooler to see the MFD screen. Should an intense hot air leakage occur, the differential pressure switch or the three massive leakage detectors will close the affected engine bleed valve and the cross bleed valve. The differential pressure switch is located at the pre-cooler. The massive leakage detectors are located in the rear electronic compartment. We will now look at the controls and indicators associated with the pneumatic system. The pneumatic system is controlled by the air conditioning and pneumatic control panel located on the overhead panel. The engine bleed valves are controlled by the Bleed 1 and Bleed 2 buttons. When the button is released, a striped bar illuminates inside the button to indicate that the button has been selected off. When off is selected, the associated engine bleed valve closes. Click on the left engine bleed switch to select the left engine bleed air on. An engine bleed valve will open when the associated bleed button is pressed in, the associated essential DC bus is powered, no massive leak has been detected on the respective side of the rear electronic compartment, no leak has been detected downstream of the associated pre-cooler, the associated N2 speed is above 56.4% RPM, and the associated fire handle is not pulled. A leak annunciation appears in the button when a leak has been detected in the associated bleed line. The APU bleed valve is controlled by the APU bleed button. When the APU bleed button is released out, the APU bleed closes. A striped bar appears when the APU button has been released out. Click on the APU bleed button to select APU bleed air. When the APU bleed button is pressed, the APU bleed valve opens, provided the essential DC bus 1 is energized, the engine 1 bleed valve is closed, the engine 2 bleed valve is closed, or the cross bleed valve is closed. The APU speed is above 95% RPM for more than 7 seconds, and no leak is being detected in the APU line. An open indication is displayed within the button when the APU bleed valve is in the open position. The cross bleed valve is controlled by the cross bleed knob. The closed position closes the cross bleed valve. Click on the cross bleed knob to place it in the open position. The open position opens the cross bleed valve, provided the essential DC bus 2 is powered and no leak has been detected downstream of the pre-cooler or in the rear electronic compartment. The auto position allows the cross-bleed valve to be opened and engine 2 is starting, or engine 1 is being started with bleed air from engine 2 or an external air ground cart. The cross-bleed valve logic automatically opens the cross-bleed valve and both high-stage valves and closes one air conditioning pack whenever the anti-ice system is operating below 24,600 feet. If both packs are operating normally, the system logic will shut down the left pack. If one pack has failed, the logic will keep the remaining pack valve open. On aircraft equipped with pressure regulating and shut-off engine bleed valves, the functional logic also opens both high-stage valves and closes one pack below 24,600 feet, but does not open the cross-bleed valve if the anti-icing system is operating. The bleed temperature downstream of the precooler is displayed on the MFD. The scale is white below 500 degrees Fahrenheit. This is the zone where the bleed air temperature may be insufficient for normal anti-icing. The scale is green between 500 to 581 degrees Fahrenheit. This is the acceptable range of the bleed air temperature. The scale is red above 581 degrees Fahrenheit. This is the over temperature zone. The pointer is amber if it is within the white scale and the message bleed 1 or 2 low temperature is displayed on the ICAS. The pointer is green if it is in the green scale. If the pointer is missing, it indicates that the respective outlet temperature sensor has failed. Numerous ICAS messages indicate pneumatic system malfunctions. A bleed leak warning message indicates that there is a duct leakage in the associated bleed line, or the temperature in the duct region exceeds 195 degrees Fahrenheit. There is a bleed leak message for bleed valve number 1, number 2, and the APU. A bleed over temperature warning message indicates that the temperature downstream of the precooler exceeds 581 degrees Fahrenheit. There is no APU bleed over temperature message. A bleed valve fail caution message indicates that the indicated bleed position disagrees with its commanded position. There is a bleed valve fail message for the engine and the APU bleed valves. A bleed low temperature caution message indicates that the associated bleed air temperature is low, or there is a failure of the precooler temperature sensor. There is a bleed low temperature message for the engine bleed valves only. A cross bleed fail caution message indicates that the cross bleed valve position disagrees with its commanded position. A cross bleed switch off caution message indicates that the cross bleed selector knob is in the closed position with at least one engine running after breaker release. A high stage valve fail caution message indicates that there is a disagreement between the position of the high stage valve and its commanded position. A bleed 1 or 2 valve closed advisory message indicates that the associated engine bleed valve is closed. This message is inhibited on the ground or during engine start of the associated engine. A cross bleed open advisory message indicates that the cross bleed valve is open. This concludes the pneumatics module.